Good evening, everyone. Joe Keane is my name. I'm a development manager for O'Callaghan Properties here in Cork. I'm also a chartered surveyor, and I've been involved now in the construction industry for over 45 years. In spite of that experience, they say every day is a learning day. And with this project in particular, it was a learning day for all of us involved. There was a lot of new stuff that we hadn't come across before, and it was pretty out front in terms of what we were trying to achieve. I would like to thank Engineers Ireland for giving us the opportunity to come this evening and to, introduce the project to you and tell you a bit about it. Hopefully you'll learn a bit so that you don't have to do what we did, learn first time around. So hopefully you'll get a bit out of the talk this evening. So our presentation will focus on the process that we engaged in over the past number of years to sustainably demolish and recycle the old R&H Hall grain silos in the South Docks in Cork. So our presentation is actually in 4 parts. So I'm going to start by introducing the project from the developer standpoint. Dr. Colin Rinn of University College Cork will explain the industrial archaeology works that were undertaken prior to the building being demolished. Martin Murphy, an engineer, a director of MMOS Structural Engineers here in Cork. Martin will detail the building surveys and the process involved to recycle the materials arising from that demolition. And finally then, Carl O'Kelly, a director of O'Kelly Brothers Demolition Contractors, will detail their role in the demolition and the recycling process at site level. So just very briefly, a bit about O'Callaghan Properties first, if you permit me, for those who don't know. So O'Callaghan Properties is a privately run Cork-based property development company. We're in business now for over 50 years. And in that 50 years period, we've developed 7,500 family homes. And we've been involved in over 5 million square feet of commercial development. And we'd be probably best known for like Liffey Valley Shopping Centre in Dublin, and the Riverlea Hotel here in Cork, and also Mahon Point and Opera Lane, and many, many other projects, large-scale projects throughout Ireland and the UK. But in recent years, our particular focus has been in the Cork Docks. So we've assembled a site of 33 acres in the Cork South Docks, and we've already commenced development there in 2016 with the construction of 2 office blocks at Navigation Square. Both of those office blocks are now fully occupied, and they were built between 2016 and 2019, and they delivered over 275,000 square feet of usable office space. The Cork Docklands as a project, Cork Docklands has been identified in the National Development Plan, the National Planning Framework, and successive Cork City Development Plans as a key growth area for the city core here in Cork. And as a brownfield city centre site, which is immediately connected to the transport hubs, public transport hubs, buses and trains, you couldn't really think of a better sustainable brownfield land bank to develop in Europe. So supporting that development, already over 500 million euros of public money has been promised through central government for infrastructure projects to incentivise and to support the private development in the Docklands. In response to that, another 500 million of private investment has gone into Docklands, and that's witnessed in the projects both North and South Docks. That's witnessed in projects such as, I mentioned, Navigation Square, One Albert Quay, Penrose Wharf, and the Clarendon BAM developments, which are underway at Kent Station. Between those projects, they've created over 700,000 square feet of commercial office, with 8,000 people now working in those offices. And, people from Cork will also have seen in recent times, there's now 500 apartments under construction on the North and the South Docks. So you have the Glenveigh project in the Marina Walk area, and you also have the Clarendon BAM project on site, which at the Kent Station. So in the next 2 years, upwards of 1,500 more people will be living locally in the Docklands. Also significantly, the preferred route for the light rail has now been published and is open for public consultation. And that's pretty significant as well as a support for the future. The LRT will run from Ballincollig through to Mahon, through the city centre, through Kent Station and on into Docklands. So this is just an image of our what we currently have planning permission for. So if this will work. So we have Navigation Square running across Victoria Road on into Kennedy Quay, the Odlums building, and back into Goulding. So that's only part of the site. But So the plans that we have already been granted planning permission on about 25 acres of the 33 acres in total. The permissions have been granted for 1,500 apartments, 500,000 square feet of commercial development, which basically encompasses everything you can imagine, mixed use, encompassing offices, retail, cafes, restaurants, cultural uses, the entire gamut. We also have a permission for a 130-bed regionally focused rehabilitation hospital. And if anybody knows anything about Cork and about health in the Munster region, Cork and Kerry and so on, you'll know that that's badly needed. So we're hoping to start that hospital in the next 12 months. So that would be the next step in the journey on Docklands. It's part of those developments that we were actually granted the permission to demolish the 2 old R&H Hall silos. And the part of the site that we're actually discussing today is on Kennedy Quay, to the east of the Cork city centre, and just to the directly east of Victoria Road. So, like every large-scale development, there's so many facets that have to be thought through before you ever get to start on site. And like simple things apart from the planning process, there's heritage, there's the receiving environment where all these new buildings are going to go, and there's sustainability. And they're just a few of the topics that we're looking just to orientate people. So the receiving environment, the Port of Cork operates from the blue area here in Kennedy Quay, and that's effectively one of the open ports in the country. So if you go to Dublin Port, you have to sign in to sign out to access the port. But here in Cork, at Kennedy Quay, that's not the case. So it's an open port. There's about 275,000 tonne of cargo coming in and out, loading and unloading at the docks there in any given year. So we had to be very conscious of our operations in proximity to the port. Also, you'll see Marina Market in the purple colouring up there on to the east of the site. About 10,000 people now go to the fantastic Marina Market every week. So there was a huge amount of footfall and local people walking up and down in and around the environs of the site. Along with that, we have residential. Some of the houses that are in that area are there for over 150 years, believe it or not. And there are other local businesses, including one of the significant local owners there in the green is Southern Milling, who've been there a long time, operating a very successful business. And we rock up and we want to do all this new development and all this demolition. So we have to be conscious of their requirements and their needs as well. And also you have the Doyle Shipping Group, who handle a lot of the cargo for the Port of Cork. So the receiving environment was very important. There's a huge amount of stakeholder engagement before we could ever think about proceeding with what we wanted to do. Given the scale of the proposed new plans for Kennedy Quay, you can imagine that there was a very rigorous planning process. And as part of that process, we had to examine in detail the heritage of the site, and in particular the buildings that were on the site, including the R&H Hall silos. In fact, the built history of the area is actually relatively quite recent. And when I say recent, I'm talking about 200 to 250 years. So if we had all wandered down to Victoria Road in the 1700s, it was underwater, all right? So it was part of the river basin, and it was under flood. So there was no navigation down this end of the city. So what happened is in around 1763, they started construction of the navigation wall. And the purpose of the navigation wall was to bring cargo ships further in towards the city centre and to extend the vertiges from the city. So more cargo, more trade. In early 70s, before the 1800s, the corporation, as now the council, they prepared a master plan for the area to reclaim that land behind the navigation wall. And then on into the 1820s and 30s, so they reclaimed the land. So there would have been a significant river dredging scheme, and all that land behind the navigation wall then was all brought up and level and reclaimed. And then moving on from that, you see the first signs of real, I suppose, civilization in the area at that time is there's a public park with a race course, and that's developed in the mid-1800s. Centre Park Road, that we're all still very familiar with, that Centre Park Road ran right through that race course and went down the centre. And then on into the emergence of milling in Ireland, but the milling in particular in Cork, and Colin will talk a bit about that later on. But essentially, that's when we start to see significant buildings being built on the quayside in the late 1800s, including the National Flour Mills, which preceded the R&H Hall development. 1917, we have Henry Ford, he comes to Cork. The city council at the time made a huge commitment to transfer land for the purpose of basically job creation and the industrialization of the area. That happened, it was successful. It was followed later then laterally by the Dunlop Tire Company as well. but milling never went away. The milling was still operating and still working. And the arrival in the 1930s and 1950s of the two grain silos was they were significant undertakings at the time, and they were very impressive buildings. So that just gives you, I think, a little bit of the history of what we would have to be considering in the built history of that area. So as part of that planning process. So we had to make a number of commitments. So prior to any demolition work starting on site, we made a commitment through the planning process to recognise the heritage of the area. And we did that. That was done significantly to conserve and restore where it was feasible to do it, to record and commemorate where necessary, and to repurpose where practical. And Colin will go into a bit more detail later on. But in terms of a couple of the facets of that, what we've done as part of our demolition process is we took a number of the hoppers from the R&H Hall silos. We've actually salvaged those along with some of the steel columns that have been supporting them for the last 100 years. They've been taken out. We've stored those, and the plans are that they'll go back in now into one of the office buildings in the lobby area. And you start to see this kind of imagery where we're carrying the old into the new. And also, there's another undertaking that we've made regarding the tallest office building, which is actually on the footprint on Furlong Road in Kennedy Keys, on the footprint of where one of the first silo 1 would have stood. And on the side of that building, on the facade of that building, we're going to commemorate in stone, on the stone facade in relief, the history of milling in the area. So they're all the commitments. That's all part of the process before we ever go near the demolition or the construction of new buildings. Sustainability. I mean, the actual driving force. I mean, the specifics of this are between 2024 and 25. We demolished the 2 silos and effectively recycled for reuse 99.7% of everything that came out of those buildings. All right, all of the materials, but significantly the piece that everybody is supposed to be familiar with it, the crushed aggregate, some 15,500 tonne was recycled as a 6F2 material, and is currently being reused now on the Irish Rail Middleton, the twin track project down at Ballyadam. So the building has now found a new purpose. Building materials have found a new purpose, and the driving force behind that approach was sustainability. So we, as a company, we've developed a number of LEED accredited buildings here in Cork, and we also had the first LEED platinum accredited project in Cork. We're also working with Enterprise Ireland under the Innovative Build programme. Reusing crushed concrete to produce the 6F2 material aligns totally with the principles of sustainability, and in particular the circular economy and the closed loop system, right? So it reduces the material flows, reduces waste generation, it conserves natural resources, and promotes sustainable practice within the construction industry. So it ticks all of the boxes that you can imagine here. All right, the waste reduction, it creates economic opportunities in a new way of looking at waste. The environmental benefits are obvious, and that's, I suppose, where we were focusing our attention before we ever started. And we did a carbon assessment, preliminary carbon assessment at the outset of the project to look just simply at 2 scenarios. One, we do what we typically would have done in the past. We crush the material and we send it to landfill. And the second scenario, which is the one that we ended up doing, is where we crush the material, we create a new type of material, and we send that to a new home, which is the train project, right? And the outcome of that, in very simple terms, is that in terms of the handling of the material itself, there was a 54% reduction in the embodied carbon, that the emissions that would have occurred by reusing the material in the other fashion. There's 2% of the total life cycle, in comparative terms, there's 2% of the total life cycle embodied carbon used in a 10,000 square metre office building. Or in layman's terms, which would be much more my line of things, a 700,000 kilometre journey by a car has been saved in terms of embodied carbon by just reusing the material in the way we have. So I'm going to hand over, if I can, to Dr. Colin Rain, the very engaging Dr. Colin Rain, and he'll take me through some of the work that we did in the salvageability of goods there. Thanks, Colin.
Good evening, friends, ladies and gentlemen. My name is Colin Rinn. I'm a senior lecturer in archaeology in the Department of Archaeology, UCC. I've been a licensed archaeologist for the last 44 years. License means that I can do excavations. I don't do that anymore. A, because I'm lazy, and B, because there's much money in it. But being less flippant, there's a lot of young people, I see a lot of young faces here, who are much better than I am. I also established, in effect, brought in my own kind of private consultancy business into the university, which this forms project part of, which has been in business really for the last 25 years, mostly operating in Ireland, but also in Scotland and in other parts of the United Kingdom. Now, my principal responsibility is, if you like, to carry out the stipulations under planning for I suppose, the performative aspects of the conservation, principally the recording of buildings, which are not going to be kept. My job is to do the primary research, identify the things that are significant, and also to kind of locate the things that we need to keep, that we need, to preserve in some way. And we'll see there are aspects of the machinery here that are very important, and again, a very involved project process, as we'll see, of recording and taking them out. Briefly about the history of the site. Again, most part of the Docklands here is developed really from the 1860s onwards. The Cork Blackrock and Passage Railway was on this site. They moved it to the other side. They moved it closer to the city to enable the commercial development of the Docklands, principally for milling, and later on, as we'll see, for grain intake and distribution. And Hall silos is one of three major complexes within the city, or if you like, the main distribution point for Munster of Southwest Ireland. There are larger silos in Limerick, but the Hall silos, the Hall complex, is actually larger than the R&H Hall complex in Dublin. The earliest silo of 1934 is built by William Littlejohn. He was the kind of doyen of kind of grain silage, grain storage engineers in the 1920s and the 1930s. He actually built 36 silos in Cape Town, South Africa. Not for South Africa, it's an important stopping off point for the British Navy up and even after the creation of the Suez Canal. So they're really making a statement here. They get the top man in Europe to actually design these for Cork. And also, in a sense, it's an architectural statement. Again, black roofs, the porthole type windows as well. I mean, this is, I suppose, an architectural statement as much about grain storage functionality. And then Le Corbusier, the Swiss-French architectural designer, call them, I suppose, the first fruits of the modern age. So very much an architectural statement here as well, but again, completely lost on the people of Cork. The second silo was added in 1952. The second silo was added in 1952, obviously as grain intake expands. From the 1850s onwards, most of the grain, most of the wheat that's consumed and stored in Ireland is coming increasingly from the American prairies, later from Canada, and in the 1940s and 1950s, even places like Argentina. Just at the back part here, there we go, just behind it, there's a railway siding added in 1945, which gives it kind of the functionality and connectivity with the main railway station at Glanmire Road. And again, you can see here, very much open, people walking along this all the time. I did work in Dublin Port last year, and they have their own safe pass before you actually allowed into the place. Also, quayside, if you're 1.50 meters from the quayside, you have to wear a harness. And you'll see young kids here in the summertime, their feet hanging out over the end. So it's very much a challenging situation for the Port of Cork, and also, as you'll see later, for the developer. Now, let's talk a little bit about grain storage. Grain, no matter where it comes from, when it comes from the crop from the field, it has about 24% humidity, moisture in it. That has to be reduced to at least 14% before it's actually stored. Then there's another process called conditioning, which when you bring it out of the silo for milling, which I'll talk about in a minute. The machine that's important here, it's the only one ever built in Ireland. Possible to find other examples or similar examples throughout Europe. So it's the only one in situ in Ireland or in Britain or Ireland when we work on it. It's still at work as late as 2019. And it's this building here behind, which we're going to look at now. This is called the receiver house. So all the grain comes in from the quaysides in this really elaborate conveyor. It falls through machine by gravity. It's brought up by elevators into storage here and into the silos here. And again, the machine opposite occupies 4 stories. And that's really the difficult. How do you get a 4-story machine out of a building like this? And when we come to that, we sleepless nights up to Christmas because this man was here. Colin, what are you going to do, Colin? What are you going to do, Colin? 10 minutes later, what are you going to do? And again, but we figured this out. Again, heads got together to sort this out. And effectively, if you include these two buildings here, it's a 10-story building. That really is the dilemma: recording it in complete detail and also removing it safely. And we have to be practical about this as well. Now, the recording of it, again, I suppose we've done something that's completely new and innovative. And we've used things or recording techniques or technologies that already exist. But it's the first time they've been brought together to allow us to affect a project like this. Now, you're probably all familiar with laser scanning at some basic level. You're using it for your surveys, you're using for your evaluations, and we use a mixture of this and photogrammetry, as we'll see. This is the first time in my 44-year career, I grew up with theodolites and tapes. Do you remember those? Yeah, the paint. Do you remember the paint of that? Do you remember pen and ink before CAD? Like, I'm the first archaeologist in Ireland to use CAD, mid-1980s, before many architects and engineers were using it. Basically because I'm lazy and it does a lot of work for me. But all of this is laser scan. The only time I used the tape was when I was trying to find out if I could get something in the door, which is kind of a brilliant way of looking at it. And again, you'll see the product that you get from this is quite extraordinary. Now, in the main silos here, there's 82 of these individual silos. The latter part is added literally in 1935. As we'll see later, we took some of these, Joe's already mentioned, we took some of these actually hopper bins out, basically because they're close to a window. There's no point in taking something here. And also safety, so you have to be practical in getting things out. That was probably the most dangerous part of the extraction process. So let's look at this machine, the grain dryer. This is a very, very schematic version of it. What exactly does it do? Well, before you store grain, as we've seen, you have to dry it. It has to be dried. That's critical. Otherwise, it forms mold or it attracts weevils. This is what happens to go. People have been drying grain in Ireland for the last 2,000 years. There's a basic grain dryer from County Kilkenny, which has a radiocarbon date of 200 BC. So it's always necessary for farmers to be able to do this. Now, what this process does, it works by gravity. There's no power activation in this. It's dropped in from the top on the 6th floor. There's a heater, which is a kind of a steam heater, which heats it. But before it goes down to the next process, lest it cracks, it's slightly cooled down before it's ignited here in the conditioning or drying area. And there's another fan at the bottom. I'll show you some examples of these in a minute. And of course, there's all kinds of ducting, there's all kinds of dust collection technology here used as well. You're just seeing something simple. I mean, you can barely walk around it in the room with all the ducting. That was the first thing that we had to take out. So that's basically the process. This is the only example that we found anywhere in Britain or Ireland, and it's the only one where conditioning is actually involved. Now, when you're bringing the grain out of the silo, if it's going to a mill, which is normally the case, it's there for animal feed, it's there to make flour or whatever. Basically, you have to add moisture to it. This is the conditioning process. So this machine then adds 1% or 1.6% moisture, really, to fortify the outside of a cereal grain. Now, a cereal grain, 80% of it is made up of the endosperm, which is the proteins that feed the germ or the embryo in it. That's basically what you're extracting to get flour. So to condition that, so make sure it's not too brittle, and to make it easier in the milling process to extract the embosade, conditioning is necessary for that. This is the only example that I've come across in Ireland. Some smaller mills around, if some larger mills have their own conditioning processes or machinery, but this is the only one that kind of does both of these that I've actually come across. So this is one of the fans. Again, what do we keep? What's important? And again, we're thinking of display. I'm also a museum professional. What could you fit in this room? 2.5 meters high to get it safely into a case to be able to environmentally monitor it. These are the kind of things that we're thinking about. Do we keep something like this to keep a memory of it, or do we keep one of the 3 machines that are there? These are the kind of decisions that are kind of forced upon us. This is one of the drying machines in the background, as we'll see. And this is one of the steam radiators. None of those survive anywhere in Europe. They're recorded, they're laser scanned, but we decided not to keep them. We decided to keep the base of the machine, which has the control panel and all the other things, which, you know, again, makes it kind of recognizably a grain dryer. And again, at the base or on the 2nd floor, again, you can see These two machines are largely the same, but we decided to keep this one. This one is more interesting for the most part. There's another one here, which is, I think, used for drying bark. A very, very complicated machine, very difficult to kind of visualize and to record in 3D. But we'll talk about that in a minute as well. So the recording and the conservation process, this is the one that we decided to keep. And the reason for that is to get that out, we'd have to knock a hole in the wall onto a road, and the same on the other side. Here, it's into a yard which is controlled by the developer. So we're being practical about that. The pretty one, we're not going to keep that. We're going to be easy, we're going to be practical and get this out safely. And again, all of this here, when it comes down to the machines, it's going up through bucket elevators up to the top to silos 1 and to silos 2 and to silos 2. We didn't keep any of those things. Again, it gives you some idea again of the complexity of this. And again, the lift isn't working. So that's 9 flights of stairs. Everybody's complaining about that, carrying everything up, carry it down. And when I was working in Dublin Port last year, I went into halls in the lift just for the thrill of being in the lift and not having to work a sweat getting up to the top. Incidentally, my senior archaeologist, Flor Hurley, he actually lives about 5 minutes away from the silos in Marina Park. And he lives with his mum, dear old mum. And even though he's 5 minutes away, she still made sandwiches for him, which is kind of nice, isn't it? So the recording. Again, sexual innovations. Now, as an archaeologist, I'm quite happy with this. It's giving me all the information I need. It's showing me the complexity of the machine. Again, we can look at it from every single angle. Okay, that kind of third angle projection. That's fine for me. And for most archaeologists, we would do some 3D stuff. Things that are very difficult to understand. But we'd only do that for a museum or for presenting to the public as well. But when we got this, a week later, gratis, we got this as well. This has come standard with the software that they now actually use. And again, anybody looking at that, it gives you a clear understanding of the process, the verticality about what's going on. And once I got those drawings, I went back again to check features, was able to add more information, to be able to explain it better to a public. And again, as a museum professional, this is what you'd like to show to the public. You couldn't show them a set of engineering drawings as well. And again, also the process back in 2021. There's not this site, it's Odlum site nearby, which has got 9 machines, which you're going to be taking out at a later date. Excuse me. When this is being displayed, how do the public to understand it? You've never seen a grain dryer before? You're all mechanical, chartered engineers. You're used to technical things. How's the public going to understand that? That's the angle that I'm looking at. Also, I'm in the education business. How's a 19-year-old or 20-year-old going to be able to understand this? And of course, the technology. 3 years ago, it was a crew of 6 people with 2 laser scanners. Now it was a crew of 2 with a single laser scanner. And also, when we took these apart, we actually surveyed the areas inside. So we got a complete 3D visualization, realization of that. Now, we also use photogrammetry. Again, a series of overlapping photographs, overlapped by 60%. I mean, is used in the Second World War, the First World War for real photographs. But the technology and the software that we have in this is fairly advanced. Now, for this particular project, we're using full frame cameras, large sensors, but they're also mirrorless cameras. They're lighter. That was handy carrying them up the 9 flights of stairs, I can assure you. So they're much more sensitive in light. This is a dark room, which you'd have to use flashes. Software doesn't really like that. It bleaches things out. So what did we do? Again, we set it up. This took about an hour to do. We set it up with particular exposures and settings, and we tested that in the software. And the software gave us that. I experimented with other pieces like this, and it gave us, the software equalizes all that. So any of you can get a camera, do all of that, feed it into the software, and this is what you get after 10 minutes. You can take measurements of it. I mean, it's the highest end of photogravity that's possible. So we have laser scanning, and we have this as well. And of course, also, we're going to have to put this back together again. When you're putting a kind of instruction manual to put those pieces back together again, this kind of information is very useful as well. So to end the dismantling process, we decided which one we're going to do. The problem is, how are you going to get it out of a 9-story building? And people thought of taking it off layer by layer, lifting it out. And we really didn't know what was going to happen here. This is kind of worrying coming up to Christmas of 2023. But then we got smart people together, particularly archaeologists, in the same room with people like yourselves. And it was all sorted in 20 minutes. Absolutely incredible process, you know, when they looked at it now. So the basic idea is this. This is on the top floor. This is on the 6th floor. So basically what they're just using a block and tackle suspended from the roof to lift out this section. They lift out that next section, then they go down to the next section and they move the other pieces next. These are battles. In this process, not to get too complicated, when the grain is falling through, these are inclined veins and it impacts against the surface. It gets singed and it flops down to another one. It works its way down to the bottom through gravity. They're quite heavy, again, but it's very easy. This is Peter. This is an amazing guy. There's no metal making trade that man cannot do, or any machine that guy can't do. He could stand. He works for this man here. I hope you're paying him. I hope you're paying him well. But again, I think it was 2.5 weeks we got the whole machine out. Okay. Now, which one do we keep? Again, there's a kind of museological angle here as well. Now, this is going to be in a museum display. It's going to be restored. It's going to be repainted as well. Some of the fixings, of course, will have to be, you know, redone. And I don't get kind of fussy about that. I'll give you an example of this. When you put something into a museum, it's removed from all use. A violin, a flute, whatever. It will never be used again. And that's the way it's conserved. That's the way it's preserved and passed on, and so on and so forth. But if you have a working machine, and if you're doing this for 40 years, obviously, as you know, you have thrust bearings, journal buzzings, fan belts, steam manifolds. They have to be replaced if it's working. So I'm not fussy about that. But because all the machines are the same, I've kept spares from all of them, fixings of all of them. I've kept the other panel in case it gets broken, or in case something can happen to it. So I'm not going to be fussy about that. Give you an extreme example. You're all familiar with Rory Gallagher's guitar in the National Museum of Ireland? Yeah. We just saw it there in April. Okay, that will never be played again. It will not be restrung. That's what happens in a museum. And if you touch it, you will be wearing gloves. That's the only way it's going to be preserved. It will be in an environment where humidity, temperature, everything will be monitored. That's what happens in a museum. But we really can't be fussy about that. This is probably the most dangerous. This is Peter, of course, who else cutting this down. And of course, the ones that we kept are the ones that are nearest to a window. We're going to be practical. You know, there are better ones there, but it's much more dangerous and much more arduous to get them out. We still have a memory of the building. These, as you saw from Joe's presentation, are going to be stored elsewhere. And this is where it's stored now, but it's actually being moved to another place. Again, it's on pallets, it's numbered, it's in an ordered sequence that it can be put back together again. It's also in a secure location. It doesn't really need kind of environmental monitoring. If this was pottery or something would, you know, we would measure humidity and things like that. So in a sense, that's the process. So what have we actually done? Basically, we've taken down the most complex machine in Ireland, one of the most complex in Europe from the 30s and the 1950s. We've used technologies that already exist. We've brought them together, experimented with them to get this specific result. We've done something new here. And the next job, I'm really going to charge for this. And again, really, literally, since the last summer, we've had conversations with people who are dealing with these things in England and elsewhere. You know, archaeologists aren't like you. We share information freely. I didn't charge for my time, even though they offered for it. So this is fed into other projects where people are going to have the same problems. We've solved some of those problems. Again, they might find other ways of doing it. So the whole thing is a rewarding process as well. I mean, so again, even though these buildings are demolished, we now have a memory, a clear memory of what it did, of the most important and rare machinery in it, which is going to be preserved and will be displayed at a later stage within the new complex, along with 9 other machines, which we identified for preservation in the Alden complex, which is next door. Thank you.
So we're just going to play a little video now, which is about 4 minutes long. It'll actually, it'll show the process in a real way of what Colin has been describing by way of photographs and stuff. And it'll take you through the demolition phase as well. There are some images at the end of the buildings we propose to put on the site in due course. But I think you're starting to gather now a little bit. When I said that there was a lot of facets involved in development before you ever get to start knocking or building, I think you get a sense now maybe of from Colin's talk there, what's involved in the archaeological heritage side of it. Now, so enjoy the video. And we're going to ask Martin Murphy of MMOS Engineers to give us a bit of a run through about the whole process involved in the recycling of the materials.
Thanks, Joe. Thanks, Colin. That was very interesting. So my name is Martin Murphy. I'm a director of Murphy Matson Sullivan Consulting Engineers. We've been in existence since the year 2011, and we've worked with O'Callaghan Properties for all of that time. And personally, I've worked since the early 2000s with Joe on various jobs from Mahon Point, Liffey Valley, Opera Lane, trying to think of them all now, Navigation Square, and oh yeah, we did the hotel and Riverlea Hotel, and more recently Navigation Square, and now we're working on the Docklands, both Gouldings and Kennedy Quay. So delighted to be still working for O'Callaghan's. So today I'm going to give just a brief overrun of the building structure from a structural engineer's viewpoint, the surveys that we undertook at the planning stage, the demolition process, which I'll be brief on, and the reuse then of the material, how we turned concrete waste into a resource, basically, in the process that underwent. So just a brief summary of the buildings. There's two buildings, as we've been calling them so far today. We've got Silo 1, which is the building at the front, and then Silo 2, which is the rear building. One is the rear building is 48 meters tall, 12 meters in width, so it's got a slenderness ratio of 4:1. And the front building is a bit wider and a bit shorter. They were, as was said previously, one is 70. It was 70 years old at the time of demolition, the rear one, and this one was 90 years old at the time of demolition. They're mostly monolithic concrete with very light reinforcing, and then, as you saw earlier, there's some steel framing on the ground floor and on the roof level on this building in particular. So the structural stability of the buildings are dependent on the external walls, which come to ground, whereas the internal walls are supported on columns. They don't come to ground. There's no internal floors. So what you have basically is you've got silo, the silos hanging from the first floor structure. You've got vertical silos in a grid shape, and then you've got a conveyor level at this area and this area here. So there's no internal floor in the whole height of the building for 33 meters for the rear building. So any modification was going to be difficult, would cause instability, and wasn't deemed feasible. And demolition was approved in a planning stage. So just a bit more on the building structure. I've kind of given the dimensions of it there already. Just I suppose one thing that's worth noting is that the height of the building at 48 meters here, it would have been the tallest building in Cork before the Elysian or the County Hall were constructed. So it was for a long time probably the tallest building in Cork. At 48 meters tall, it would be the equivalent to a 16-story residential building at that height there. This is a structural drawing that we produced just to give it more information on it. So you can see this is actually the structural drawing of Silo 1. There's a grid of steel structure up to the underside of the hopper level, columns at the same spacing as the internal walls in the north-south direction, and in the east-west direction they skip out every second. So those beams are carrying a double silo. So you can see the height of the silo there, and then you've got the conveyor level at the top, which is a steel structure on a concrete roof. So you can see on that's the crucifix column in the Silo 1, and there's steel beams on the top. I'll show you more on that now on the next slide. The hoppers were fixed then up to the underside of the structure. That was Silo 1, which was the 1930s building. The 1950s building then was a concrete frame building. Both, I'll get on to another slide and I'll show you that now in a minute, but both buildings had tiled foundations. And as I said earlier, the stability was dependent on the external walls, which were lightly reinforced. So across the top is Silo 1. So you can see the distinct difference in the structure. This is the 1930s. These are the columns now that will be preserved. You can see the rivets and the base plate details. So this is pre-war. You can see the steel beams then at the underside of the hopper, and you can just make out the hopper there, which is that concrete that extends 30 meters up into the air. And then at this level, then you've got the conveyor level, which is a floor of itself, which is really the only suspended floor in the building. And you've got a steel structure then supporting the roof. This is silo 2, then you can see that you could actually Colin had a better drawing of the ground floor earlier, but you can see the stocky columns here that support the roof. There's a reasonably heavy structural slab, which the silo walls are built off, which extend up 33 meters in this case. And then you've got a nice picture here of the structure of the top floor, which is a concrete level. You can see the holes there that are the access manholes down into the. So if you fall through one of those, it's a 33-meter drop down to the bottom of the hopper, which is at this level here. And you've got the conveyor then running along with which divider either side, which shows how the silos are actually filled. We did some surveys then, pre-planning, just to get the condition of the building. So the visual surveys showed us the decaying concrete, spalling, showed poor exposure conditions, from water ingress, chemical attack, all sorts of deterioration. So you can see a close-up photograph of that. Verticality surveys then show that the building was off plumb by 140 millimeters, which wouldn't be acceptable in modern building standards. We also did concrete testing, which showed some of a big variation in the concrete actually, but I just highlighted that the weak concrete 13 and 12.6 Newton per millimeter squared, which would be very low by modern standards. The cores also showed poor compaction in places, segregation of concrete, so poor placement, I suppose, and some carbonization issues as well on the concrete cores. Now, so after the decision to demolish was made at planning stage, we looked then at the demolition stage at the reuse of the materials. So just a quick brief review of the legislation. So you've got the Irish Waste Management Act, which basically sets out how waste is processed, and just that's an interesting statement that I pulled out. The Waste Management Act imposes a general duty of care on holders of waste under which a person may not hold, transport, recover, or dispose of waste in a manner that causes or is likely to cause environmental pollution. So suppose if you have that in your mind at the start, it's probably not a bad starting point. So the EU legislation then followed 2011 up to I think 2020 actually. That gives a definition. In 2018 there was a definition provided when waste ceases to become a waste and how that works. It promotes the recycling of materials. So for the construction sector, the two relevant articles in the European directive are Article 27, which relates to byproduct of waste, which wasn't relevant really for us, and Article 28, which was relevant, which sets out how material recovered from waste is deemed no longer to be a waste. The particular document then that we'll focus on now is this document here, the National End of Waste Decision for Recycled Aggregates, and that sets out how demolished aggregate becomes a recovered material. So that's the statement at the top of the document determines when recycled aggregate resulting from recovery operation ceases to be a waste. It came into effect on the 12th of September 2023. Now, if you think about the timeline of that, 2023 was when Colin was taken, up to Christmas was when Colin was taking the machines out of the building. So this landed around the same time. So it's pretty new in terms of what we were doing. If you think about the fact that in 2024 the building was being demolished and crushed. So concrete that falls from the building during the demolition process is a waste. It's defined as a waste. At that particular time, that concrete on the ground there is a waste. That concrete is a waste. So what we had to do was to determine how that waste could be utilised for the end use, which was envisaged, which we had a need for, but someone had a need for, and that was to provide a base layer for a railway track down in Middleton. But it could be other uses as well. It seems obvious, but I suppose we want to show you how we step through the legislation, how we get there. So the key definitions in the document, that's the recycled document here, the EPA guidelines, the National End of Waste Decision. That's the document that I'm referring to. It's a 17-page document, and I'll just be stepping through that there for a few minutes. So the producer, which in this case was Carl and his company, they're the people who hold the license to waste operation licenses. They're the people who produce the waste from the demolition process. A batch then is a term you hear a lot. A batch has maximum quantity of 2,000 tons. It's material that comes from the same original source, produced at the one time, and it's considered a single unit. The user then, in our case, would be BAM. Can be a manufacturer or a supplier, but in our case, it was the contractor, the constructor, and they were the people who would have the end use for the material. So there's loads of suitable inputs for what can become recycled aggregate. but in our case, it's the concrete waste from the demolition process. So the important points to make about that is it cannot be a hazardous material, and it cannot contain certain materials such as asbestos, obviously, epoxy resins, paints, organic pollutants, and other deleterious materials such as pyrite and dangerous concrete stuff. There's a treatment process required, and that treatment process includes the crushing, grading of the material, which from a material point of view defines it as a 6F2 material, the assessment of that from a physical and a chemical viewpoint, and then the separation of that material into batches which each have a unique identifier. The quality of the recycled aggregate. So these are the checks that you must run through in the document. So each batch of the material should conform to a customer or industry's specification. In our case, we have a customer or BAM who want to use the material, and the industry specification is the 6F2 material. The recycled aggregate needs to be deemed a construction product. So that means that it falls within the scope of the construction regulations and should comply with a harmonized aggregate standard. Sampling and testing was undertaken in accordance with, as set out in the document, so Table 2 and Table 3. Table 2 is an assessment of solid waste, and Table 3 is an assessment of leachate waste. Then there's instructions on stockpiling, so how you stockpile the material should be easily identified. And also an interesting point is that after 24 months, the material ceases to be an aggregate, and it would revert back to be a waste. At that point, you would have to do additional testing to redefine it back to a resource. Specific uses then are set out in the document. In our case, a road construction or railway ballast it would be an acceptable use, and that's an unbound use. They have also bound use. You can use it in non-structural concrete. You could use it in making Kelly blocks and that kind of thing. But it also sets out the restrictions, right? And key point here is you can't be used as a construction material within a building. It's not suitable in a building. It's actually not suitable within a couple of meters of a building, and so it's really for hiding mats, for road makeup, that kind of stuff. There's also certain information about proximity to water and that kind of stuff. So the sampling and the testing that was undertaken by us, and it's also part of the requirement. As I mentioned earlier, there's two tables. There's table 2, which sets out the solid pollutant limits, and table 3, which sets out the leachate pollutant limits. It's similar to the European WAC criteria. That one is some of that is as well, but I think there's slightly different limits. So the testing was undertaken each batch up to 2,000 tonne, as I said. It was, and this is all set out in the document. The samples are collected from the site and tested at a laboratory, by an accredited laboratory, in our case BHP. We also witnessed the samples. So each sample that was taken away to be tested, I think there was 10 of them in total, 10 samples. Mott MacDonald, on behalf of BAM or the Irish Rail, who were the user, O'Kelly's, was Carl's company, the producer, and ourselves. We were all present for the sampling and witnessed the sampling, witnessed it being taken away by the testing company, which is BHP. We also undertook a visit down to the railway site, because if you remember, there are some uses that are acceptable and some uses that are not acceptable. So we had to satisfy ourselves as the producer that the use that was been described to us was the correct use according to the document. So another important aspect of the document is the statement of conformity. This is associated with each batch of material. So each batch of material has a statement of conformity that gives the details of the producer, gives dates, sets out the specific uses, and it needs to be completed and issued with the transportation of the material. Once it leaves site, this documentation has to be in place. So there's other issues, other bits in there about retaining it for 5 years and that kind of stuff. The other important aspect of that, which is associated or a requirement of the statement of conformity, is chain of custody. So the chain of custody, the person who is responsible for the chain of custody is the holder. The holder of the material at a particular time must have this chain of custody up to date. And that includes the producer's information. So if you think about it, once it's left the yard, we have no more effect on it, but it has to revert back to us to see what we did with it. And the haulier details, who's transporting the detail, other holder details, who's transporting material, other holder details, and then the end use information. That's always on the statement of conformity and also on the chain of custody. It goes back around. So that's a kind of a circular thing that you must maintain oversight of, but the responsibility is with the holder. And then I think this is my last slide. I just want to mention a bit about WERLA. So during the process, we met the Cork City Council, and we met the professionals from WERLA, the Waste Regional Lead Enforcement Authority. So WERLA were involved in the project. They're the competent authority with oversight. My understanding is that they assist the local authorities. They're brief allowed them to visit the site. The reason that they were interested in what we were doing is because of the Article 28. They emphasized to us the importance of the chain of custody, and the checking and the delivery dockets, and also the management system. So the documentation, the Article 28 documentation sets out the requirement for a management system, that you have an approved management system that records it, and that has to be a certified management system. We had 3 meetings on site with WERLA. We had an initial site meeting when the contractor was present, and then with the design team and contractor were present, a second meeting where we reviewed all the documentation and the testing requirement during the crushing of the material. And then just as the material was leaving the site, there was a final inspection just to review all the delivery documentations and that kind of thing. So thank you very much.
And lastly, Carol O'Kelly of O'Kelly Brothers will go through the demolition. Thanks, Joe, Martin, Colin. My name is Carol O'Kelly. I've been a chartered engineer for 11 years, and I've worked in the demolition industry for nearly 25 years. Firstly, I'd like to extend my thanks to O'Callaghan Properties, in particular Brian O'Callaghan and Joe Keane, for awarding us the contract for the Kenny the Key project and the demolition of the R&H silos. O'Kelly Brothers is family run and in business for over 70 years. We've built a reputation as a trusted specialist contractor delivering complex demolition and deconstruction projects across Ireland with an emphasis on safety, sustainability and compliance. Our expertise spans industrial, pharmaceutical, commercial and urban environments, and we pride ourselves on delivering end-to-end solutions from soft strip and asbestos removal to full structural demolition and advanced decontamination. At the core of what we do is a blend of traditional knowledge and modern innovation, always with a focus on material recovery and environmental responsibility. Now backwards. Before any machines arrived on site, O'Kelly Brothers were involved in this project from the early planning stages, working closely with O'Callaghan Properties and their design team to assess how demolition would impact both the immediate surroundings and the wider city environment during the transition to construction. The scope of the works. This slide outlines the full scope of works we delivered on the Kenny the Key project. Over the next few slides, I'll take you through a brief overview of each element, touching on the key challenges, approaches, and innovations involved in safely delivering each aspect of the job. Community stakeholder engagement. Stakeholder engagement was a major focus on this project, given the sensitive city centre location and the scale of the works. We began by sitting down with our client, O'Callaghan Properties, particularly Joe Keane and Sean Finn, to work through and justify the proposed demolition methodology in detail. This helped ensure alignment and confidence in the strategy moving forward. From there, we maintained transparent communication with key external stakeholders. Cork City Council, especially Anthony McCarthy, played a critical role in agreeing the traffic management and hoarding layouts to support safe public interface during the demolition. The local residents committee was engaged early, and we continued to work closely with them throughout the works, keeping lines of communication open and proactive. I'd also like to thank John Toomey of Southern Milling, whose cooperation allowed us to coordinate heavy plant activity around their live operations. And to Henry Kingston in the Port of Cork, who provided essential support in integrating demolition activities with daily port movements, ensuring zero disruption. From the environmental side, we liaised closely with Niall Dunn from WERLA and Mairead Long from the Cork City Council environmental team, both of whom were instrumental in reviewing and supporting our Article 28 process. Throughout the works, we issued regular look-ahead updates, including letter drops and flyers to nearby residents and businesses detailing upcoming phases and any likely impact. A complaints protocol was in place, but I'm pleased to say we never needed to activate this. That speaks to the level of care, planning and respect that went into how this project was delivered. So dilapidation surveys. Before any work began,
we carried out comprehensive dilapidation surveys of all surrounding buildings and public areas. It ensured we had a documented baseline, giving all parties confidence in the integrity of the process. We gained access to the solar milling complex, as well as residential and commercial properties along Victoria Road. We also recorded building elevations on Victoria Road and Furlong Street, noting visible facade and structural conditions. On the public side, we surveyed road and pavement surfaces along Kennedy Quay, Furlong Street, Marina Walk, and Victoria Road. Protection of live services was a key priority, with water, gas, and electrical mains running close to the site along Kennedy Quay, Furlong Street, and into substations on Victoria Road and Furlong Street. To mitigate risk, we installed crash decks, steel plates topped with 500 mil of crushed concrete to shield critical utilities during the demolition. Importantly, we used recycled material from early engaged concrete crushing to build these decks, reducing imported material and supporting our sustainability goals. This approach combined infrastructure protection, carbon reduction, and smart material use, all planned from the outset. Traffic management and pedestrians and vehicular traffic was a key issue. Demolishing a 48-metre tall concrete structure just 9 metres from live occupied offices introduced very real engineering and public safety challenges. Our core responsibilities was to instill confidence into staff working just metres from the works, many of them sitting at desks directly overlooking the silos. It reminded us of the Sullivan's Quay Tax Office project in 2018, where we faced similar constraints and delivered it with 0 incidents and complaints. Pedestrian traffic at the site was consistently high. We recorded around 100 movements per hour along the boundary, often just a few metres from demolition operations. That required careful, designed public interface with robust exclusion zones, consistent supervision, and real-time monitoring. We installed custom hoarding made from ballasted shipping containers, avoiding the use of traditional timber and concrete blocks. These containers offered a dual purpose: strong physical barrier and secondary an acoustic and debris shield. This wasn't just a practical solution, it reflected our commitment to sustainable practices by using reusable materials and reducing site-generated waste. To further protect the public realm, we installed a debris curtain system suspended from a mobile crane positioned along exposed elevations. This acted as a physical barrier for any stray fragments and offered visual reassurance to pedestrians passing through the area. Environmental monitoring. In a busy city environment like Kennedy Quay, air quality, emissions, and noise are critical concerns. Monitoring was key for both compliance and public reassurance. We installed real-time monitoring sensors on all 4 sides of the site to track air quality, noise, and vibration, with automatic alerts triggered for any threshold exceedances. All plant used was silenced and emission compliant, and we enforced a strict no idling policy where we trained the operators to ensure environmental standards were upheld. To reduce congestion, we ran just-in-time logistics system, truck times slots, no roadside staging, and live coordination with delivery drivers. This helped keep the site running efficiently and support pedestrian safety, particularly with up to 20,000 pedestrian movements per week passing the boundary. The salvaging of the archaeological equipment. Prior to the salvage and demolition operations, we carried out a full temporary works assessment inside the structure to ensure it was safe for both salvaging of the archaeological elements and the heavy demolition operations. This included backpropping key areas, verifying floor loading limits, and installing edge protection and exclusion zones. We worked closely with Colin Rain and his team to document and safely salvage these items. Lifting operations were carried out under strict control with an appointed person, lift supervisor, and a rigging crew on site at all times to ensure both structural safety and the safety of the heritage equipment. All items were carefully handled, logged, and transferred off-site for conservation and future display. So the demolition methodology. We carefully considered several demolition methods for Kennedy Quay before selecting high-reach demolition as the most appropriate solution. The wrecking ball method, which is still in use in certain scenarios, presents high risk of uncontrolled debris spread. The precision of this method is typically poor, and given the tight site boundary and public interface, it was deemed unsuitable for this project. Top-down demolition using scaffolding and small mechanical plant was also considered. However, this method is highly labour-intensive and time-consuming. It significantly increases the risk profile of the project due to the extended exposure of personnel working at height. It also presents challenges in managing the structural instability as the building is deconstructed. Controlled explosives while exciting, was unfortunately not the deemed suitable for the project, for the simple reason proximity of occupied buildings and public footpaths just meters from the structure made this method unacceptable from both a safety and a planning perspective. After a thorough review of the site constraints, public safety and environmental risks and program requirements, we determined that R&H demolition was the safest, most efficient and most controlled approach. It allowed us to progressively reduce the building's height from a safe distance while incorporating robust dust suppression, vibration control and public protection measures. Let me share some key stats about the R&H machine that we use for the project. The machine was sourced in Europe and is one of only 9 in the world. When fully rigged and operational, it weighs in at just under 170 tons. It is capable of operating with a 6-ton demolition attachment at a reach of up to 50 meters. It makes it ideal for tall reinforced concrete structures like the silos on this site. The R&H method allowed us to safely and efficiently demolish both silos in 36 days. Alongside the R&H, we used a fleet of secondary 50 to 75 ton excavators. These machines were critical in supporting the operation. They were used to prepare and maintain work platforms, manage risings, clear debris at the ground, and stay ahead of the R&H, ensuring continuous progress without delay. The synergy between the main machine and the supporting plant was key to project success, enabling safe, well-sequenced demolition in a confined live environment. What many people wouldn't realise is that the logistics of mobilising this machine is a project in itself. It travels on 4 articulated lorries with components split for safe transport. Boom alone, when in transport mode, is longer than a tennis court. Guard escorts and coordination were required to move it throughout the country. When it's travelling on the motorway, it doesn't travel at speeds of over 50 kilometres per hour. And that's just the Irish side of the operation, not to mind the ferries and crossing through the UK. So the silo demolition solution. For silo 1, constructed from reinforced concrete and featured a complex internal cellular structure, a key factor that added significant complexity to the demolition process. As visible in the image, the internal layout consisted of multiple interlinked vertical cells, which required a careful, sequenced approach to maintain structural stability. Each chamber wall had to be systematically broken out, progressing in a controlled and safe manner. It is worth noting that the internal cell walls were only 100 mm thick, meaning they offered limited residual strength once adjacent sections were removed. This further emphasised the need for a methodical and engineered approach. Silo 1, the north silos in particular, was relatively straightforward in layout. It consisted primarily of a honeycomb cell arrangement with some low-level plant areas. We adopted a step-stair demolition sequence, which allowed us to optimise the use of the building's own structure to support the works as they progressed. The approach enabled us to systematically reduce the height of each cell, working progressively towards the northeast corner and maintaining safety throughout. The demolition of the second silo structure presented additional challenges compared to the first one. On the eastern side, it housed a large plant area containing the 3 dryers that Colin took us through there, multiple elevators and extensive ductwork. This section required special consideration due to the large open internal spans needed to accommodate the equipment. With the walls of 100 mm thickness and floors of only 150 mm thickness and no internal bracing, these elements offered minimal shear resistance, making them structurally vulnerable once isolated. To manage this risk, the demolition sequence was carefully planned. We prioritised the removal of the plant area before completing the demolition of the cellular compartments and the lift and stair cores. This ensured stability was maintained in the critical structure elements for as long as required. From a logistical standpoint, we also staggered operations for efficiency. While the smaller machines were preparing the footprint from the first silo to accommodate the R&H excavator, we simultaneously began removing up to 60% of the second silo's western elevation. This parallel sequencing helped keep the programme on track and ensure the R&H machine remained productive throughout. So crushing and reclassification of the concrete. This project was delivered under strict quality environmental controls, particularly in compliance with the Article 28 end of waste regulations. We started with intrusive asbestos, hydrocarbon and lead surveys, followed by the preparation and execution of removal plans. This was essential to ensure no hazardous materials compromised the final recycled product. A comprehensive saw strip was carried out to remove any non-compliant materials like plastic, insulation, timber, and painted finishes that could interfere with the end of waste criteria. The works were guided by rigorous inspection and test plans developed in collaboration with both the client's project engineers, Martin and his team at MMOS, the end user BAM, and Matt McDonald's, their engineers, ensuring alignment from start to finish. Demolition was carried out in a sequence and control manner with on-site segregation of arisings and crushings and batching of concrete materials. We followed ISO 9001 standards for sampling, testing, and quality assurance, with full chain of custody documentation in place to support the traceability, final use of the recycled materials. The results speak for itself. O'Kelly Brothers achieved a 99.997% material recovery rate, a near zero waste outcome that sets a benchmark for sustainable demolition. I wish to take a moment to acknowledge the entire team at O'Kelly Brothers, from the planning and engineering leads to our site crews, machine operators, and environmental specialists. This project was a success because of their professionalism, dedication, and precision. I'm genuinely proud of how the team delivered such complex and high-risk demolition in a live urban environment, all while maintaining our standards for safety, sustainability, and stakeholder respect. As we wrap up, it's important to reflect on where our industry is heading. Construction materials are evolving, fire strength concretes, composite reinforcements, and hybrid structures are now common. But with innovation comes complexity, and that directly affects how we will demolish these buildings in the future. That's why the idea of design for deconstruction is gaining traction. We must shift from a linear approach to a circular model where materials can be safely and efficiently reclaimed and reused. The cycle is no longer just design, build, and use. It must now include dismantle and reuse. As demolition professionals, we're not just the last step, we're a critical part of the sustainability chain. And as an industry, we need to think further ahead, because ultimately, the structures we erect today are the ones someone else will be responsible for taking apart tomorrow. Thank you very much.